Turn your books to page 801. We're going to talk about circle graphs. We are going to make a circle graph to represent the following data. So we have books in the bookmobile. We have fiction, nonfiction, children's books, and audiobooks. The first thing we need to do with those is we need to add them up. So we're going to take 110 plus 40 plus 300 plus 150. We get 600 books in the bookmobile. Now we next need to figure out what percent or what fraction, essentially, of each book we have. So fiction, we have 110 out of 600 books are fiction. Nonfiction, we have 40 out of 600 books. Children's books, we have 300 out of 600. And audiobooks, we have 150 out of 600. Now, the next step is to find out what degrees of the circle, what percent of the circle. Essentially, circles come in degrees because we have 360 of them in a circle. So we need to find what degrees each piece is going to be. So what we're going to do to find that is we're going to take our fraction or our percent, because 110 divided by 600 is a decimal and is a percentage, right? We're going to take that times 360. We're going to take 40 over 600 times 360. We're going to take 300 over 600 times 360. And we're going to take 150 over 600 times 360. And we're going to find our degrees. This one, 66 degrees. Does that sound right? 66 degrees. 24 degrees. 180 degrees, because it's half of the books in the bookmobile. So it's half of the circle graph. And this one is a quarter, so it'd be 90 degrees. Of course, you can multiply those on your calculator and it'll spit out those answers for you. So now we're going to make a circle graph for each one of those figures. First one I'm going to make is the children's books. I'm going to start with the easiest one, the one that's half of the circle. I'm going to cut my circle in half. And that one's going to be my children's books. Okay. That is half of my circle. Now, the next one is audiobooks is 25% or 90 degrees. So that one's, ooh, that was not good. I want the skinny one again. Actually, let's go a little bit fatter. And the audiobooks is 25%. Don't mind my artistic abilities here. Just coloring it as fast as I can here. So there's our audiobooks. And now the other one, again, if we wanted to get super technical, we'd measure this with a protractor. We'd come up with 66 and the rest would be our 24. But I'm not going to get real crazy with it right now. So I am going to just cut it where I think it looks pretty good. So there we go. And we're going to color fiction as our bigger one. Fictions are 66. and nonfiction is our little guy here. And there's our nonfiction. Okay. So how we find the degrees that they are is we take their percentage or their fraction or the decimal. I guess they're all the same, really. Fraction, decimal, and percents are all the same. We take that times 360 degrees to get that portion of the circle. Does that make sense? How we make a circle graph with that, multiplying those?
What were the percents for fiction and nonfiction?
Fiction was 66. And nonfiction was 66 degrees, sorry. And nonfiction was 24 degrees. Questions on that? Gonna need to know a little bit of that for today, because we're going to look at circles with some percentages, and we're going to have to figure out how many degrees those parts of the circle are. All right. Okay. I want you to do numbers 1, 2, and 3 on the bottom. I mean, you could probably do them right now, but that's part of your assignment for tomorrow. We're also going to continue on into .2. So turn your books to page 802, please. 802, please. We are going to apply properties of arcs today. We're not going to talk about chords today. We'll talk about chords tomorrow, or I will talk about chords. You'll probably just listen, watch the video, learn how to finish that. Okay, so you will listen to those chords. Yeah, you don't have to find that because you have your height in base 1. You need to find base 2. So 1/2 times base 1 plus base 2 times height equals that. That's your area. Okay. So we're going to apply properties of arcs today. Tomorrow we'll talk about chords. I won't be here tomorrow. I have a sub. We're going to Grand Forks for golf, so I'll be gone, but you'll watch the video, do the lesson. It'll probably be a 20, 25-minute video, and you probably get 20 to 25 minutes to work in class, which is awesome, because then you can get that homework done prior to Thursday. All right, central angle, arc, minor arc, major arc, semicircle. We're going to talk about most of this today. Everything except for congruent arcs. That's the only thing we'll talk about tomorrow. A central angle is an angle whose vertex is the center of the circle. So the central angle is that part that cuts out and makes that piece of pie, like that pizza, that whatever you cut, that's the central angle down in the vertex, down in the center. An arc is an unbroken part of a circle consisting of 2 points called endpoints and all the points on the circle in between them. The arc is the actual piece of the circle. It's actually that curved part of the circle, okay? A minor arc is an arc whose points are on or in the interior of a central angle. So here's a central angle, ABC. The minor arc is between A and C, and we actually call it arc AC. It is also equal to the measure of the central angle, and of course, whatever X is there, okay? The major arc, or a major arc, is an arc whose points are on or in the exterior of the central angle. So it's in the exterior of this central angle. There is no central angle out here because we don't have angles that are huge, okay? Our angles are usually less than 180 technically. So the major arc is the piece of the circle that's on the outside. The measure of the major arc is always 360 minus the minor arc, or minus the central angle. So 360 minus this central angle will give us the arc degrees. A major arc is always labeled with 3 letters. A minor arc is always labeled with 2 letters. Don't forget that. Semicircles, also always labeled with 3 letters. A semicircle is half of a circle, half of an arc, okay, or half of a 360-degree circle. It's the half arc. It's 180 degrees. So in the lesson today, in your examples, in the problems we do today in class, we're going to use a lot of these diameters to help us find angle measures, okay? So pay attention to that today. Minor arcs are 2 points. Major arcs are named by 3 points and semicircles. So make sure you remember that. When you're naming a major arc, 3 letters. Any 3 will do that are on the major arc. Doesn't matter which ones, but you need 3 of them. I shouldn't say it doesn't matter. The starting point and the ending point have to be first and last. The one in the middle doesn't matter. You can just pick a point that's on the arc. Circle graph shows the types of grass planted in the yards of one neighborhood. Find the measure of arc KLF. So I go to K, I go to L, I go to F. So it's this arc here. I want the measure, that's what this little M means, measure of arc KLF. So what I'm going to do is I'm going to find the minor arc. I'm going to add these together, find the minor arc and subtract that from 360. So 20 plus 8 plus 7 is 35 percent, excuse me. I'm going to take 35% times 360, or 0.35 times 360. That gives me a measure of 126 degrees. So from here to here is 126. I'm going to subtract that from 360. That will give me then the measure from here to here, the measure of the major arc. So the measure of arc KLF is 234 degrees, finding the major arc. That makes sense? That's what we just talked about in the circle graphs. These are percentages, which are also decimals, which are also fractions. That's what we would multiply by 360 to find each one of these parts. But we don't have to find each one of them separately, do we? We can find them all together, can't we? Questions on that one? Finding the measure of the arc? Okay. Use this graph to find each of those following. Find the measure of angle FMC. Find the measure of arc AHB, and find the measure of angle EMD. Find those using what we talked about in that last part. All right, letter A, FMC, FMC. If we add these three together, we get 30 degrees, 30%, excuse me, 30% times 360 degrees is 108 degrees. The second one, AHB, if that's a major arc. So if we subtract the minor arc from 360, we should get the major arc. The minor arc is 25%, which is 90 degrees. So if we take 360, subtract 90, then we should get 270 degrees. So the major arc should be 270. Remember, we want to go AHB. We have to go around. Remember, when it's three letters, it's a major arc. When it's three letters, it usually should be more than 180 degrees. The last one, EMD. EMD is just country, 10%. So 10% of 360 is 36 degrees. 36 degrees. 10%. EMD, this purple sliver right here, 10%. So it's 36 degrees. Questions on those? All right, adjacent arcs. Adjacent means next to. Arcs that are next to each other share an endpoint, okay? They intersect at exactly one point. So S in this case would be the point where they intersect. So RS and TS are adjacent arcs. We have something called the arc addition postulate, very similar to the angle addition postulate and the segment addition postulate and all of the addition postulates we have. It means if we want to know arc AC and we know arc AB and we know arc BC, we can add those two together and we get arc ABC or arc AC. Okay? Add the two small arcs, get the big arc. All right, find the measure of arc BD. We want to find the measure of BD. We want this whole arc here. So I'm going to find BC and CD and then add them together. BC is 97.4 degrees because these two are called vertical angles. The vertical angle theorem allows me to match up these two angles because they share the same lines, which makes them vertical angles. Vertical angles are always congruent. So BC is 97.4 degrees. CD, to find CD, this one gets a little bit trickier, but what do we have here? That's a semicircle. So we know this is 97.4. This is 52. This is whatever's left over out of the 180, right? So we're going to take 180 minus 97.4 and 52. And we get 30.6. We know CD is 30.6 degrees. So now we know that 97.4 and 30.6 degrees added together will give us arc BD. So I'm going to add those two together. And I get 128 degrees. So arc BD is 128. So when you want to find a bigger arc or arc made up of several arcs, add the arcs together. All right, do this one. Check it out. Number 2, do 2A and 2B. Sorry, do 2A and do 2B, please. Do 2A and 2B, please. All right, let's take a look at these. Find each measure, the measure of arc JKL. So JKL. The first one we can find is JK. That's 25 degrees because it's a vertical angle with MN. These are vertical, so that's 25. I also know that this angle here, this line here is a diameter. So this is a semicircle. So this has to be the difference of 180 minus 65, technically, or 25 plus 40. So that angle is 115. So 115 plus 25 is 140 degrees. So the measure of arc JKL is 140 degrees. To be LJN. That one's pretty easy because the only thing it doesn't encompass is these two arcs, which are 40 and 25. So all I do is subtract the minor arc or the central angle from 360, and it gives me the major arc of LJN. Sorry. So 360 minus 65 is 295 degrees. You could name this LJN, you could name it LKN. I mean, it doesn't really matter. That middle one is just whatever one you want to pick there. It's everything except for the 65. Any questions on that one? Okay, rest of the time is yours. I don't have any more for you. You got about 10 minutes, 15 minutes here. Work on that assignment 1 through 3 and 19 through 28, 33, and 36 for tomorrow. Tomorrow, again, I hopefully will get you some more time to work on that assignment. I will be recording a video for tomorrow's stuff. Have that ready for you.